we're going to take the next topic and split it into two parts. So we're going to be simplifying radicals, and in this part specifically square roots. And they're ones we're more familiar with, so we'll do those and work through those and hopefully get very good at them, and then we'll apply the same principles to higher roots, such as cube roots and fourth roots. So here, simplest radical form means simplifying a radical so that there's no more square roots or cube roots or fourth roots within the radical to find, and it also means making sure there are no radicals in the denominator of a fraction, or even I could have put in no fractions in a radical, and we'll deal with that part later. But for right now, we're going to be simplifying square roots, no fractions as of right now. So just so you understand, to simplify means we're going to find another expression, and I defined how to simplify radicals up here. We are not just putting this in our calculator to get a decimal. We're not putting the square root of 32 in our calculator to find out what that is, that it's some decimal approximation like 5.7 or something like that. So here's what we're going to do. We're going to split this into kind of two parts or two steps. First, we're going to look at simplifying constants within a square root. And you see the steps here, and I'm not going to look through them here because we'll look through them as we do the example. The second part is going to be simplifying variables within a square root, and then actually our last example will be, it will have a constant and variables. So here we go. We have three examples here, and we're going to work through these steps. Reading through these, hopefully these make sense to you. So some of you I know learn better by reading things, others by seeing things. So let's take a look here. First, find the largest perfect square which will divide evenly into the number under the radical sign. So I take 8. I want to find the largest perfect square that divides into 8. Now here I listed the first 15 perfect squares. We're never really going to need to use 1. So really we're going to be working with these other ones. So we want to find the largest number in here that goes into 8. And it's simple to find in this one. It's 4. So what we're going to do is we're going to write the number appearing under your radical as the product of a perfect square and the answer. So we're going to say, okay, well, this is the square root of 4, and then 8 divided by 4 is 2. So we're really rewriting 8 as 4 times 2, and we're choosing 4 because it's a perfect square. Next, we're going to split this up, and we're going to give each number its own radical. So square root of 4 times the square root of 2. Evaluate the perfect square. So square root of 4 is simply 2, and we're left with 2 times the square root of 2. This is simplifying it. Square root of 8 in its simpler form is equal to 2 root 2. I should say simplified form. Next one is square root of 96, a larger number. So let's take a look at this. We want to find the largest perfect square that goes into that. So 4 goes into 96 24 times. 9 I don't think goes into 96. 16 goes into 96. I believe that goes in 6 times. 25 won't. 36 doesn't. So 16 is our largest. And if you didn't know that by memory, you can just take 96 divided by 4, figure out what that is, and actually do the problem. 96 divided by 16, and that's 6. So you might need to divide to figure that out. And now what we're going to do, so we found the largest perfect square that goes evenly into it. We're going to split this up. Square root of 96, we're going to write it as the square root of 16, the perfect square, times the answer here, the quotient, times 6. And we're going to split this up into two parts. The square root of 16 times the square root of 6. We know the square root of 16 is 4 times the square root of 6. So that's our simplified version of the square root of 96. So 4 root 6. And then our last example here, this I want to show you something that might help. Instead of finding the largest perfect square, what we can do is we can try to simplify this sum, and once we simplify it some, maybe we can simplify it some more. So This is an option if you have a very large number. So right here, I know for sure that 100 goes into 35,000 because it has two zeros. So I know that 100 goes into it. Maybe some of these other larger numbers go into it, but what I'm going to do is start by simplifying this 100. So I can rewrite 35,000 as 100 times 350. And I can split this up. This is the square root of 100 times the square root of 350, which I know is 10 times the square root of 350. But I really didn't think through this 350 yet, so I might want to find it or see if there's a perfect square in 350. So 4 going into that, you could divide 4 into that, which I don't think works. Yeah, it doesn't go into it. The rule for 4 is if it goes into 50 evenly, it will go into the whole thing. 9 doesn't go into it. That you add the digits up. 3 plus 5 is 8. 8 does not go into, or 9 does not go into that. 16 won't work because 4 didn't work. So let's try 25. 25 definitely goes into it because there's a 50 here. So 350. So a little work off to the side. Divided by 25, this is 1. And so we get 14. And so I know that I can split this up. So I still have the 10. Don't lose that or drop that. Times the square root, and 350 we can write as 25 because that's a perfect square, times 14. And now we're doing the same thing we did before. We'll split this up into the square root of 25 times the square root of 14. And the square root of 25 is 5 times the square root of 14. And so we have 50, because 10 times 5 is 50, times the square root of 14. And that is our simplified version. What we did, we saw quickly 100 went into it. We could have figured out that 2,500, which is a perfect square, went into it. That's 50 times 50. But we're not really familiar with usually 50 times 50, so we did this in 2 parts and got to our simplified answer. So that is simplifying the constant term within the square root. Now we're going to look at simplifying the variable or variables within a square root. Here's the steps. So we'll take our first example and work through these steps. Separate each variable into its own radical. So we'll go ahead and make this the square root of w to the 6th times the square root of x to the 4th times the square root of y times the square root of z to the 4th. So we split each variable into its own part. And now what we're going to do is we're going to remember that the square root means what times itself gives this number. And then we're going to try to simplify these, and some of them are going to be simpler than others. So the square root of w to the 6th. So what times itself equals w to the 6th? Well, w cubed, as long as you remember your rules for exponents, w cubed times w cubed will equal w to the 6th because we add those exponents. So the square root of w to the 6th is w cubed. So I took the square root of w to the 6th, got w cubed. I've seen a mistake of people still putting their square root there. We took the square root, so it's just w cubed. What times itself will give you x to the 4th? Well, x squared times x squared gives x to the 4th, so this is x squared. What times itself gives us y? Well, nothing. That can't be simplified, so we'll leave that as the square root of y. And then this one's similar to the x, so what times itself gives z to the 4th? That's z squared. And then the last thing we want to do is we want to put our things that do not have a radical on the outside. And then on the inside, we just have square root of y. So next one. We're going to do the same steps. We're going to separate this. This is a cubed times square root of b to the 7th times the square root of c to the 20th times the square root of d. This one will have couple new things to work with, and actually we didn't even get to the step 3. We didn't have to do the step 3 in the example, so we'll be seeing that here. So square root of a cubed. There's nothing times itself, no whole number times itself, that gives us a cubed. Or so I shouldn't say whole number. So a cubed we can't get. It's not a simple one. So what we're going to do is we're going to split any variables that can't be simplified easily into 2 factors. One being a perfect square, and really the largest perfect square that we can use, and the other the leftovers, and I'll explain what that is. So a cubed is not a perfect square, but a squared is. We can take the square root of a squared. So we're going to write a squared times a. And then b to the 7th, well, b to the 7th isn't a perfect square. Now, with b to the 7th, we could write that as a couple different ways. That we could think of that as b to the 4th times b cubed, but we don't want to do b cubed because that can be simplified even more. So we want the largest perfect square, so b to the 6th. We can think of that's our largest perfect square, and then the leftover, which I was mentioning, would be b. So this is going to be b to the 6th times b. The next one's a simple one because what times itself gives c to the 20th? Well, c to the 10th. So we can figure out that one. This is just c to the 10th, no more square root. And the last one, square root of d, we can't simplify that, so we'll leave it as the square root of d. Now what we're going to do is we're going to look at these ones that we started working with, and we're going to simplify. Well, this is the square root of a squared. And this line, eventually you might be able to skip this line because you'll be familiar with how this works. I'm going to split these up just like I did with the numbers, the constants in the last several examples on the other slide. And what's the square root of a squared? Well, that's a. So we have a times the square root of a. What's the square root of b to the 6th? So what times itself gives b to the 6th? That's b cubed. Can't simplify this anymore, so that's just square root of b. We still have the c to the 10th and the square root of d. And now the last thing we want to do is we want to simplify and combine. So we simplified, and now we want to combine. So our things that aren't in the radical we'll put out here. So we have an a b cubed, c to the 10th, and then within the radical, and so we can make one large radical, we had an a b, and a d. And so that's our simplified version of the square root of a cubed, b to the 7th, c to the 20th, d. Our last one combines the different things that we learned. It has a constant and it has variables. So with the constant here, we want to try to figure out, are there any perfect squares that go into this? Well, no evens do because this is an odd. 9 doesn't go into it. Yes, which is 3 squared. 25 doesn't go into it. 49 does go into this. And so if you need to, you divide that out and you realize this is, we're going to split this up and write the square root of 49 times 3. We're going to give each of these variables, like we learned in these 2 steps, their own radical. Here we know the square root of 49 is 7, so we have 7 times the square root of 3. The square root of n we can't simplify. What times itself gives n squared is n. And then this one is an odd number. We're going to split this one up because there's nothing times itself that gives p to the 17th, so we're going to split this up into p to the 16th times p, square root of p. And p to the 16th, instead of writing another line, I'm going to realize what times itself gives p to the 16th. Well, that is p to the 8th. And now what we can do is we can take anything outside or not in a radical. So we have a 7, an n, and a p to the 8th. And then inside the radicals, we put the 3, m, p. And that is our simplified version of that one. so that is simplifying square roots. We did constants and we did variables